AMD team up. A future core chip will have Radeon graphics inside. It sounds crazy, but it's true. Arch rivals AMD and Intel have teamed up to co-design an Intel Core microprocessor with a custom AMD Radeon graphics core inside the processor package, aimed at bringing top-tier gaming to thin and light notebook PCs. Executives from both AMD and Intel told PCWorld that the combined AMD-Intel chip will be an evolution of Intel's 8th generation H-series core chips, with the ability to power manage the entire module to preserve battery life. It's scheduled to ship as early as the first quarter of 2018. Though both companies helped engineer the new chip, this is Intel's project. Intel first approached AMD. Both companies confirmed. AMD, for its part, is treating the Radeon core as a single, semi-custom design, in the same vein as the chips it supplies to consoles like the Microsoft Xbox One X and Sony PlayStation 4. Some specifics, though, remained undisclosed. Intel refers to it as a single product, though it seems possible that it could eventually be offered at a range of clock speeds. The linchpin of the Intel-AMD agreement is a tiny piece of silicon that Intel began talking up over the past year, the Embedded Multi-Die Interconnect Bridge, or EMIB. Numerous EMIBs can connect silicon dies, routing the electrical traces through the substrate itself. The result is what Intel calls a system-in-package module. In this case, EMIBs allowed Intel to construct the 3-die module, which will tie together Intel's core chip, the Radeon core, a next-generation high-bandwidth memory, or HBM2. The story behind the story, you heard right, this is AMD and Intel, working together. Shaking hands on this partnership represents a rare moment of harmony in an often bitter rivalry that began when AMD reverse-engineered the Intel 8080 microchip in 1975. But in graphics, the two are much more cordial. Intel's low-end, integrated cores own the majority of the notebook PC market, while AMD is pinched between Intel and Nvidia's high-end chips. Intel, meanwhile, is no friend to Nvidia, having paid out $1.5 billion in licensing fees since 2011. The enemy of my enemy is my friend, that's one explanation for how the deal came about. Intel showed a reference notebook of the sort that will be enhanced by the AMD-Intel partnership. The large, black blank space is designed to be used for drawing with the stylus and for other digital content creation. According to Chris Walker, vice president of Intel's Client Computing Group, Intel had a problem. AAA gaming PCs were selling, customers were interested in VR. But notebooks with the graphics horsepower to run them were thick and heavy. Customers, though, were seeing growth in 2-in-1 PCs and even thinner thin and light PCs. This was what Walker called Intel's portability obstacle. How could it bring top-tier performance to notebooks that didn't weigh a ton? The answer, as it turned out, was the EMIB, a small sliver of silicon to bridge discrete logic cores within a single chip package. Intel had originally developed the EMIB as an alternative to what's known as a silicon interposer, the floor foundation of a multi-chip module. The problem with an interposer is that, like a floor, it needs to cover the entire space underneath the module, making it expensive to manufacture. EMIBs are more like small connectors that dip into the substrate. Intel found that they worked for its Altera programmable logic line as well as its more mainstream PC microprocessor designs. In fact, this is the first consumer use of EMIB, executives said. This slide, taken from an Intel presentation, shows how Intel believes its embedded multi-die interconnect bridge is more cost-effective for connecting chips than methods that use an interposer, and far higher in performance than multi-chip package designs. Intel's EMIBs, though, allowed another important advantage, modularity. Originally, Intel positioned EMIBs as a tool to mix and match chips using different process technologies. When designing a programmable chip, adding in third-party logic cores is somewhat common. With an integrated logic as complex as a microprocessor's, though, it's nearly unheard of. The AMD allowed for a compromise, placing CPU, GPU, and memory in close proximity without being part of the same actual design. That paid off almost immediately. Intel still being cagey on all the benefits of the Core Radeon module that AMD enabled, but the company revealed too. According to Walker, the module stripped out a whopping 1900 square millimeters, 2.9 SQ from a more traditional motherboard, where the processor, discrete GPU, and memory were laid out next to one another. Put another way, the AMD layout consumes just half of the typical board space, Intel says. Second, the module uses about half the memory power of a traditional design. An example of the space savings Intel achieved by moving the CPU